One of the most important data structures for any data scientist to get used to is going to be the Pandas Dataframe. Now, Pandas is a third-party package available for the Python programming language. And in this video, we're going to be taking a look at 5 extremely important concepts that any data scientist or really any programmer that's ever going to interact with Pandas should know. If you guys find this video useful, make sure you like and subscribe. But for now, let's get right into it. Now, the first thing you're going to want to make sure you do before we even get started is to install the Pandas package within your virtual environment. To do that, simply come over to your terminal or your command line and type in the pip install pandas command. And if you press enter, I already have it installed on my machine, but this will actually extract the pandas library from the PyPy repository and give you access to all of the different data types and data structures that we'll be working with in this video. Now, assuming you've installed the pandas library, the first thing we're always going to want to do, and this is typically the industry standard, is come to the top of our script where we will be using the pandas library and type in the command import pandas as PD. And for those of you who are newer in the Python programming language, you can sort of give a nickname or alter the nomenclature of a library by using this as command and passing a more syntactically shorter representation of the library you're working with. And in the data science community, the PD representation of pandas is typically what is used. Now, the first thing we should cover is how exactly do we create a data frame. Now, if you look at the pandas documentation, which I will link down in the description below of this video, there's a couple of different ways we can go about creating data frames. However, one of my personal favorite ways, because I find it to be the most intuitive, is just by creating a Python dictionary and feeding that as an argument to the data frame class. For example, let's say I had a dictionary called fruit data and I had one key called fruit, another key called price, and I represented all of these entries within each as a list. Well, in terms of Microsoft Excel, essentially what a data frame is going to do is it's going to make the keys the column of the data frame, and it is going to make the row entries, whatever we have supplied, as the elements to our list values here. Once we have a data dictionary, creating a data frame is as simple as using the data frame class object from our pandas library. Notice how we have to do PD because we need to get access to the data frame class currently stored within our pandas library. But all we have to do is simply supply the fruit data dictionary to our data frame class as an argument. And this indeed creates an instance of a dictionary within our script. In order to print out the contents of a data frame, typically you're going to want to use either the .head method, which by default gives us the first 5 rows of a data frame. And if I were to go ahead and actually run my script, you'll notice that indeed I have a data frame whose columns are fruit and price and whose row entries correspond to the entries we supplied within our dictionary. As you could probably guess, if we had a mismatch of arguments here, a null value would be imputed once we would create the data frame instance to make sure we have an equal number of elements within each of our corresponding lists. The other useful method for printing out the contents of a data frame is the .tail method. As you could probably infer, this actually gives us the last 5 rows of a data frame. And so for this example, we have 6 rows. And so with the .head method, we got the first 5. With the .tail method, you notice all we do is simply drop apple and add in peach. Now, the second important data structure within the pandas library, in addition to the pandas data frame, is what we will call the pandas series. Now, essentially a pandas series is just a simple way to represent the columns of a data frame. So if you wanted to think about it, really a data frame is just the combination of multiple pandas series sort of wrapped in this data frame object. And so to create a pandas series object, we can actually index a data frame similar to how we can index other Python data structures such as lists or dictionaries. For example, if I were to use the following syntax and I supplied the name of our column to the set of open and closed square brackets with our data frame specified out ahead in front of these open and closed square brackets, this will actually create an instance of a pandas series within my script. And so to go ahead and check, if I went ahead and printed out the results of my fruit series, you'll notice that I get a slightly different result. I don't actually have a column name here. Rather, I have the name attribute already sort of like pre-built and output within my terminal. All I have within this like single dimension pandas series are the names of the fruits. Similarly, if I were to go ahead and print out the results of the price series, I would get the exact same thing, just with the values of the prices as the elements within the rows. Now, so far we've talked about how to actually construct data frames and series, but what if we wanted to extract specific elements from our data frame? For example, if our data frame was 3 columns by whatever 6 rows, what if we wanted to extract the element from the 5th row but the 3rd column? Well, this is actually known as data frame indexing or data frame slicing, but whichever way you want to look at it, the Pandas library actually affords us the ability to extract this information via 2 ways. These 2 ways, and specifically these 2 methods, are what we will call the .lock LOC method and the .iloc ILOC method. And just to help keep things straight in our mind, I typically think of the I in the .iloc method as meaning the word integer, and you'll see what I mean by that in just a few seconds. Now, to give you guys an idea of how to use these methods to index data frames, let's go ahead and update our fruit data dictionary here, and let's add an additional column called weight, which is going to like pseudo represent the number of ounces that each fruit would weigh. If we were to create a new updated data frame, I can actually extract elements using the .iloc method as so. I supply the name of our data frame out in front, apply the .iloc method, and here's an important caveat. Normally, Python class methods are invoked with the open and closed set of parentheses. However, this is not so with Pandas data frames. Instead, you use the open and closed set of square brackets, and you supply the number as an integer of the row you wish to extract, as well as the number of the corresponding column that you wish to extract in the second space, or as the second element to this quote unquote like list type argument. An important thing to also keep in mind is that Pandas dictionaries, as is consistent with the Python programming language, are actually 0 indexed. And so even though it might be easy to think that this means I would like to extract the entry from the 1st row and 2nd column, it would actually correspond to I would like to extract the 2nd element from the 3rd column. And again, this is because data frames are a 0 indexed type data structure, as is evident by our series representation. If I were to go ahead and run my file, you'll notice that indeed we get the number 24 returned back to us. And if we were to go ahead and think about this, if I were to print out the contents of our updated data frame head, you can see by using the .iloc method, I want to extract the 0 first element from the 0 1 second and technically 3rd column, and indeed this is the number 24. Now, remember earlier when I told you guys that I like to think of this I as meaning integer? Well, that's actually because the .loc method without the integer actually allows us to pass in as an argument for indexing the names of the columns we wish to extract. So for example, if I modified our script slightly here, and instead of .iloc, I used the .lock method and supplied as the first argument the row which I would like to extract, but also supplied as the second argument the name of the column I would like to extract, this will actually yield the result of the first entry in the price column. And again, just to go ahead and prove that, I can go ahead and print the contents of my data frame, and indeed the first entry of the price column is $1.29, which is exactly what we got by using the .lock method right here. Now, what if I wanted to select, I don't know, multiple columns instead of just a single column from our data frame? Well, we can actually use this syntax here, which states, hey, give me all elements that are within the 2nd row of the fruit and weight column from our data frame. But if I go ahead and run this, you'll notice we get a slightly different syntax here. We get fruit and weight as our indices, but we also get the value of banana and 24 returned to us. And so using the .lock method in this form actually imputes the columns as the index to this data structure. And if you go ahead and print the type of the data structure that is returned to us using this syntax, you'll notice that it's actually a series. And so as a result, if we wanted to just create a series using the 2nd row and the fruit and weight column, we could do so by using this .lock methodology. Now, I hope you guys are finding this information useful in trying to understand the Pandas library within the Python programming language. But if you feel like you're not exactly up to snuff on your Python programming skills, I've actually created a course that I'll link down in the description below of this video, where me, a self-taught programmer, has assembled a software engineering in Python course containing information and presented information in a manner that I wish I had it presented to me back when I was learning Python for the first time. In the Introduction to Python module, we go from just declaring variables if you've never coded before, all the way up to unit testing, class methods, and functions, and realistically learn about all things in between. The course is only $50. There's a 100% money back guarantee within 30 days if you guys aren't satisfied with it. And again, I'll link that down in the description below. But now back to the video. Now, in addition to just indexing a data frame using the .iloc and .lock methods, or even just simply supplying the name of the column following our data frame to be able to generate a series, there's actually one more extremely useful way to index a data frame, and that is what I call Boolean indexing. You see, Boolean indexing is a very intuitive way to extract useful information from our data frame based upon a given condition. And technically why it's called Boolean indexing is because Pandas underneath the hood is actually evaluating the true false reality of the elements of the data frame in the context of the conditional statement applied. Now, I know that sounded extremely complicated, so let's just go ahead and take a look at an example of what I'm talking about. Let's say I wanted to extract all elements from my data frame where the price was over $1. Well, I could use this following syntax here to do just that. And while this might seem a bit esoteric in nature, reading from left to right in the way that I'm going to read it right now should actually make this a more intuitive operation. What we're actually saying here is return all elements of the updated fruit data frame where, I like to substitute the word where in for this open bracket, all values of the price column from the updated fruit data frame are greater than or equal to $1. And if we were to print the results of this resulting data frame out within our terminal, you'll notice that indeed we get the result below, where all the fruits that are greater than $1 are present simply because underneath the hood, Pandas was smart enough to evaluate everything with a price of over $1 as true and everything else that was under $1 as false, and actually drop all rows that had a false result based upon the conditional statement applied. To showcase another example, let's say we wanted to extract all fruits from our dictionary where the weight was equal to 10 ounces. Well, again, we could say extract from the updated fruit data frame where all entries from our weight column from the updated fruit data frame are equal to 10 ounces. Again, if we were to print out the result of this data frame here, you'll notice that indeed we get all fruit that are equal to 10 ounces in weight from the data frame that we constructed earlier. I would highly recommend you guys get familiar and comfortable with using Boolean indexing, because when you're dealing with data frames that can get upwards to 10 million rows, it's going to be very easy and very useful to be able to slice that and filter that down based upon some type of condition. Now, the final topic that we're going to discuss in today's video is this idea of concatenating a data frame. What does that mean? Well, just like how string concatenation in Python allows us to add two strings together, essentially concatenation in the Pandas data frame world allows us to do the exact same thing, namely by joining two data frames together. And this is extremely useful because more likely than not, you're going to be extracting data from different types of CSV files or different types of Excel files within your day-to-day job. And so being able to concatenate all this information together is going to make analysis much easier when you go to analyze the data. So let's just go ahead and do an example using the .concat method. So I've created two data dictionaries here that are sort of just subsets or just smaller versions of the data frame we had before, right? I have a fruit column, I have a price column, and along with different row entries in each. I go ahead and create each data frame here using my pd.dataframe class. And just to verify that these are indeed data frames, I'll go ahead and print it out and we get the results that we expect, right? The fruit and price column, the first one has the rows apple, banana, pear. The second one has the rows fruit, peach, and kiwi with their corresponding prices. Now, concatenating these two data frames is literally as simple as just using the pd.concat method and supplying as a list the number of data frames that we wish to concatenate. I also always like to supply this ignore index argument because it allows us to reset the indices when joining these two data frames together. And if I were to go ahead and print out the results of this combined data frame, you'll notice that I've combined these two data frames vertically on top of one another. And as a result, we get one single data frame with all of those fruits that we had supplied above joined together. However, a great question that you guys are probably wondering is, well, this is really cool that we can stack dictionaries, but what if I had, like, let's say another bunch of columns that I wanted to join together with this data frame along the column axis? Well, the concat method actually allows us to do just that. If I were to go ahead and come back up, if I were to go ahead and use the following syntax here, let me go ahead and create a third column here by using the same data frame syntax above and supplying this data dictionary as the column to this data frame object, I can actually concatenate along the column axis as long as I pass this access one argument over here. Now, an important thing to call out is by doing this operation, it actually drops the names of the columns. And so a very useful attribute of a data frame is the .columns attribute, which actually returns to us a list of columns that are currently represented within the data frame. However, by setting it equal to the list that contains the number of elements that satisfy the column dimension, I will actually be able to overwrite the currently existing columns to be able to create something new, or in this case, reset it to what it would have been prior to being dropped. So just to show you guys how this works, if I were to go ahead and print out the results of our final combined data frame, you'll notice that indeed I have one giant data frame with a fruit, price, and weight column with all corresponding rows placed into their correct columns accordingly. And so there you have it, guys. Everything you need to know about a Pandas data frame. I hope you guys found this extremely useful. Like I said before, data scientists need to know how to use Pandas, and I actually will be creating a more in-depth walkthrough of the Pandas library within the data science module that I plan to release within my software engineering course later this winter. That's going to do it for this video. Like and subscribe if you found this helpful, and I'll see you in the next one. Later.